All right. When it was an x squared, you could factor. When it was an x cubed, you have to do synthetic division, correct? And we have to do synthetic division until we get ourselves down to an x squared where we can factor. We agree? Every single time we do synthetic division, it drops us down a degree. So yesterday we did x cubed, and then it dropped down to x squared, and we could factor. We agree? So we're going to do synthetic division with an x to the 4. What's it going to drop me down to? An x cubed. And then I'm going to have to do what? Synthetic division again, just like yesterday, and then quadratic. So it's just an extra synthetic division. So what's an x5 do? Synthetic division knocks you down to an x4. Synthetic division knocks you down to an x3. Synthetic division gets you down to an x squared, then factor. Okay? So it just makes you do more synthetic division. And in the end, you'll always type in what you're trying to do synthetic division on. So if you're trying to find it for the x cubed, you'll type your x cubed equation in and look for a root. You don't type the original back in. Every single time you're doing synthetic division, it's of what you're punching into your synthetic division. So the possible zeros for this x4 to do synthetic division would be plus or minus 1, plus or minus 3, I forgot the 2, plus or minus 2, plus or minus 6, plus or minus 9, plus or minus 18. So that would still be a whole bunch that I'd have to test out if I didn't have my calculator, right? How would we test these out? We'd use remainder theorem, and we look for when the remainder is 0, because when the remainder is 0 is when my y is 0. Yeah. So in a written response on the diploma, you're proving that it works anyways in your synthetic division statement because you're showing that there's a 0 in the remainder box. So you could arrow out and say the remainder is 0, therefore this is a factor, right? But remainder theorem is just proving that the remainder is 0, but synthetic division, you still prove the remainder is 0. So it would just be kind of redundant. I would expect you wouldn't have to. I don't know. So what do? We type that into our y equals, or we test 1 and negative 1, 3 and negative 3, 2 and negative 2 until we get a 0 in the box. Does anyone have one that works? Negative 1? So I'm going to use negative 1. You could use whatever you want. Just know that if you're using a different one, your x cubed below is going to be different than mine. Okay? Is that wrong? No. You're just going to be following a totally different pattern. But in the end, you should still have the same factors. What do I always have to check before I start putting my numbers in? That the x's go down by 1. I have to check if I can count down. So I have 4, 3, 2, 1, 0. They do, so I don't need a placeholder. Okay? You have to remember to check for placeholders. If you're someone who's still like, yeah, I would have forgot to do that, put yourself a little star, star, star at the top and say, remember to check if I can count down, and if I can't, I need to put a 0 in for the one that's missing. Right? You need to be an advocate for yourself and leave yourself little notes to remind yourself of what you forget. Because if you have a little note with a star, I promise you when you go through your notes, you'll actually pick that up and look and be like, oh, right. I have to remember to do that. Okay. So we put in our coefficients. We have 1, negative 3, negative 7, 15, 18. I did not draw my line long enough. And it's the exact same as yesterday. Drop down the number, multiply, add, multiply, add, multiply, add, till we're done. And we hope we get a 0 at the end. Negative 1 times 1, negative 1. Add, negative 3 minus 1, negative 4. Multiply, negative 1, negative 4, positive 4. Add, negative 7 and positive 4, negative 3. Bless you. Negative 1 and negative 3, positive 3. Add, 15 and 3, 18. Negative 1, 18 is negative 18, and I get a 0, and I'm happy. What's my factor that I found from this one? I currently have one factor. X plus 1, because I have a root at x equals negative 1, so I have an x plus 1 factor. Maximum, how many factors is this degree 4 graph going to have? 4. A degree 4 graph looks like a W or an M. Back when my last name used to be Wagner, I'd be like, a positive graph, Wagner. Negative graph. Ah. So, because the arrows, yo, what's up? Because you multiply. -1 times 18. So let's remember that when it was a degree 1, we had one x-intercept at max, and we always had to have 1, right? You couldn't have 0 because the arrows are going in opposite directions. Then a degree 2, we could have none, where the entire thing's above the x-axis or below. We could have 1 where it just touches the x-axis and bounces up, so it's tangent. Or we could have 2, but maximum the degree, 2. Then cubic, we said we could have max 3. We'd have to have for sure at least 1, because the arrows are in opposite directions, it's going to have to cross through. Or we could have 2, where it hits here and it bounces back up. Or we could have 3 where it goes through. Ooh. Now, a degree 4 is just like a degree 2. Even degree functions are very similar, and odd degree functions are very similar. So this is like a quadratic in the fact that you could have no x-intercepts. We agree? The entire w could be above, and you'd have no x-intercepts. Or you could have 1 where it touches down like this and then does this. Or you could have 2. Pretend those actually touch. They don't. Or you could have 3. Or you could have 4. We agree? So even functions can have no x-intercepts or increments up to their degree. So for example, a degree 2 could have no x-intercepts, 1 x-intercept, or 2. So degree 4 could have no x-intercepts, or 1 or 2 or 3 or 4. But we max out at the degree. Does that make sense? So let's factor the rest of this. So we have an x plus 1 factor. This is x to the 4. Then this is going to be x to the what? It drops it down by 1 because you've taken 1x out. And now we just have a cubic function. What do we do when we have a cubic function yesterday? We typed it into our calculator. So degree 5 is just going to get one more synthetic division. You have to do it to get to degree 4, then do it again to get to degree 3, then do it again to get to degree 2. What's one that works? Does anyone get one? -2? So that's my root, and that's what I would plug into remainder theorem, but what's my factor? X what? X plus 2. Yeah. Right here. Those are just the coefficients. Because remember when I drew this up here, I ditched all the variables and just put coefficients. So now I have to put the variables back in. And I took an x out here. So instead of this being x4, I've literally just GCF'd an x out. So now it's x cubed, x squared, x. Always drops by 1. Yeah. Yeah. So we drop to 1. -2 times 1 is -2. Add them. -4, -2 is -6. Multiply -2, -6 is +12. Then add -3 plus 12 is 9. Then multiply -2 times -2 times 9 is -18. Add is 0. And we're happy when it's 0 because that means the remainder is 0, and that actually was an x-intercept. Because remember, the remainder is also just the what value? The y. And this is my x. So that's actually a coordinate on this graph, is it not? Okay. Now, it was x cubed. I took an x out, so now I'm at x squared. And now I factor. What times what equals 9? What plus what equals -6? -3 and -3. So I have x minus 3, x minus 3. So when I go to write out my factors, I would have x plus 1, x plus 2, x minus 3 squared. And that's if it says factor, and we would be done. We agree? Because those are factors. So you've done the whole time since you've learned how to factor. Factors are what's in brackets. What? Yep. Yeah, because you've taken this out now, and that's why you have an x cubed. So this is a factor. this is a factor, and these two are factors. So you have to remember to carry them through, which people remember in a multiple choice because they'll have to go back and decipher through. But on a written response, they'll sometimes drop these ones off by accident, which we don't want to happen. So what if I asked you to solve, though, instead? If I said factor, you're done. If I said solve, what's my answer? X equals what? You had to go that one more step further last year, except you only had 2 factors instead of this many. What are your x-intercepts? -1, -2, and 3. And what you say is multiplicity. I know, exciting. You'll say 3 multiplicity 2. Because if you don't follow behind with anything, there's no remnants of telling me that there's actually 2 x-intercepts that are the same. Nope. The right multiplicity 2. Yeah. Right. Or triple. You could have 3 at the same thing, you'd be multiplicity 3. Because that's the only way that me, looking at the answer, knows that there's 2 there. Is that it says multiplicity 2. If there's nothing there, then I just assume it to be 1. I would just write it beside. I just ran out of room. I would literally go -1, -2, -3, and then I would keep going multiplicity 2. I just literally ran out of room. But I would write it on one line, same height. Now, if I ask you to factor and you give me both answers, 4 is better. No, it's not. No, it's not. It means you don't actually know what I'm asking you, so you give me every single answer you could possibly come up with and hope to God I just mark it right. Okay? No, you would actually be deducted. If you add more than what's asked of you, they will take marks off. Because if I ask you to factor, I'm not asking you to solve. That's the answer, correct? If I ask you to solve, you have to go to here. If you only give me this answer, are you done? Am I going to give you full marks? No. These are factors. These are roots. Solve means determine what x equals. Factor means give me the factors. Understandable? You'll be asked for both. You need to know what the difference is. All right? So for F, I want you to factor and solve. So I want you to tell me if I asked you to factor what the answers would be, if I asked you to solve what the answers would be. Speak gets me to use theirs. X equals what? -3? So I get x plus 3. Now remember, if you did not use -3 and you used something else, don't go feverishly erasing. That does not mean you're wrong. It just means that you probably picked a different one. Absolutely fine. Don't go erasing. So you'd have 4, 3, 2, 1, 0. We can count down. Drop the 2. -6. Add it. -3. Multiply. +9. Add it. -8. Multiply. +24. Add it. -3. Multiply. +9. 0. So we have 2x cubed minus 3x squared minus 8x minus 3. Which one works for the cubed one? X equals 3. So my factor is x minus 3. Drop the 2. 2 times 3 is 6. Add them. 3. 3 times 3 is 9. Add them. 1. 3 times 1 is 3. Add them. 0. And then I drop 1. So it's 2x squared plus 3x plus 1. And then I have to do decomp because I have not a 1 in front of the x squared. So what times what equals 2 multiplied? What plus what equals 3? 2 and 1. Replace this with 2x and 3x. 2x squared plus 2x plus 1x plus 1. Had you done them the other way, 1x plus 2x, you'll still get the correct answer. Your factors will just be opposite. Yeah. Yes. So we take a 2 out and an x, and we're left with x plus 1. If you go to plus 1, we're left with x plus 1. Had you had them the other way, the common factor would be 2x plus 1. It's the same thing. Take an x plus 1 out of both, and you're left with 2x plus 1. So if I asked you to factor, for factor, my answer would be what? P of x equals x plus 3, x minus 3. Shh. Quiet, please. X plus 1. If I said solve, my answers would be x equals negative 3, x equals 3, so they'll often go plus or minus 3 like that. If you put them as negative 3, comma, positive 3, you're just fine. It's usually put them together. Negative 1, and what's 2x plus 1 solved? Negative 1/2, because we just go 2x plus 1 equals 0, subtract the 1, 2x equals negative 1, divided by 2, x equals negative 1/2. Now, if they give you volumes of shapes, you can find the length, width, and height by just doing synthetic division, because it'll give you 3 factors, which is the length, width, and height. Okay, that's all it's asking you to do. All right. So I'm going to give you some questions to work on, to complete, and then the last 10 minutes of class, I'm showing you one little thing.